Hi, my name is Jason. Today we're going to be going over find all duplicates in an array. The solution I'm going to be going over is going to be the solution without extra space and in linear runtime. Just briefly, if we were to solve this with extra space needed, potentially O of n space, we could solve this just by iterating through the array and storing all the numbers we visited in a set. And when we come across an element that already exists in the set, we know that this element has already existed and we can add it to a result array. However, for the constant space solution, there's two things that we can note. The first thing that we can note is that all the elements, all the n in nums, let n represent the n in nums, is going to be less than equal to, all the n in nums ranging from is going to be in the range from 1 to n. And that elements that are duplicated appear only twice and others only appear once. So what that means is what we could do is we could actually treat each of the elements in the array as an index. So for example, let's say we're currently at this element here, we're iterating through. What if we could store in this array whether or not we visited an element? We could store it perhaps by using a negative sign, or by flipping the sign, I mean. So for example, if we're at index 0 and we're looking at element 4, we can visit the 4 minus 1 index 3 and change a sign of this element in the array. And what we can do is you can basically visit all the elements in the array. So for example, 3, we go to index 2, flip the sign, go to element 2. In this one, we take the absolute value of this element, which is 1. We flip the sign, continue to the next element, go to index 6, flip the sign, go to index 8, which is index 7, flip the sign, go here, element 2. And here's where things get interesting. This one we refer to index 1. And if we go right here, that would simply mean we've hit the sign, so it's positive. Go to the next element, go to index 2, flip the sign. Finally, go to index 1, which is 0, and flip the sign. And now that we've iterated through the array and flipped the signs of all the numbers that have been visited twice, you can note that these two numbers are currently positive. And that basically means that these elements have been visited twice. Of course, there are two other positive indexes. Sorry, there are two other positive numbers, but the thing is, we don't actually visit those elements in the array. Elements 5 and 6 do not exist in the input, so we're not going to visit those. We're mainly concerned about these right here. So now we can actually start coming up with a solution. So very simply, we have the resulting array. What we can do is you can iterate through all the elements in the array. Simply say, get the current number, get the current n number, so 4, 3, 2, subtract it by 1, because the array is 0 index, flip the sign of it. And once we traverse that once, we can iterate through the array again, and we can simply say, if the current index is positive, then we can simply add that number. And finally, just flip the sign, because we want to make sure we only add that element once. You could also use a set for this, but I just prefer using an array. Finally, at the end, we can just return the resulting array. We can go ahead and submit this, and we should see that we have a working solution.